the loss, right? And if we work backwards now, if you take a look at the loss depends on reducing the error. And error depends on A2. A2 depends on A1, W2. A1 depends on X and W1 and B1. So what it will do is it will end up evaluating this entire graph. And because we asked it to minimize the loss, okay, each time it will do one back propagation and one adjusting of the weights. Each time we call this. Okay, so this essentially is like a gradient descent operating on the entire data. If we wanted to change it to, let's say, a batch mode, how will it look like? So let me try the above. Okay, so then I say, let me show you. So anyway, these will be graphs that will look like with 5, 10. So it turns out 10 performs the best. This is corresponding to the hidden neurons of 10. This is 20, and this is 5. Okay, and whatever the accuracy is obtained. Okay. So implementing mini batch. Okay. So the key concept I wanted to show you here is, the rest of the code is same as before. Okay, take a look at previously, when we were going through a number of epochs, there was no J loop over here. We simply had said session.run and we had said train, right? Which basically minimizes the loss and which further goes back and evaluates A1 and A2. Okay, so now, for example, let's say batch size is 10. So you can see this will go 0 through 12, meaning 0 through 11. Okay, so each time we'll pick small part of the data. So feed dictionary will become whatever j+1 batch size, and same for y. Okay, now suppose we wanted to now, okay, because in that graph that I showed you, we were trying to display loss with respect to iteration or epochs or whatever, however you want to think of it, right? Okay, so what I wanted to do at the end of the, so if we have 120, right, each mini batch is 10, 10, 10. So in the last 10 one, I wanted to now store the loss in a variable so that we can plot it later on. Okay, so that's why, but if this is the very last part of the batch, then put the loss plot. So store the loss in this one. Okay. Okay, there was one key concept over here. Let me see if I can show it to you. Okay, this part over here. Okay, if you can take a look at this part. So, what are we asking it to evaluate? We are asking it to evaluate two expressions, right? One for loss and one for the train, so that it can further evaluate all the expressions. Okay, like I said previously, we did not have the loss. The train itself will back propagate, and so if we did it two separate times, if I did, for example, session.run and just ask it to evaluate train, and then feed dictionary, whatever, then did session.run loss. Okay, this is what I was trying to see. What will happen is it will evaluate the graph twice. Okay, so whatever that graph is, whatever we are computing. Okay, so train will go through it, feed the data, whatever data we were feeding. Okay, evaluate it. Now we want the loss. Let's pretend somewhere here is the loss, somewhere here is the train. Okay, it will again feed the data and run it through again. So So the key thing is, if you wanted some values of the intermediate nodes, okay, make sure you specify the entire list one shot. Okay, don't do it a little bit later, even though it will give you the results. You're unnecessarily executing things 2 times. Okay. Okay, so okay, let me go 5 more minutes, then I'll stop. So all of this handout will be there if you can try it. So now one of the downsides of the code that I showed you so far is, if you take a look over here, it's not organized very nicely, okay? And that's why, you know, even for me to remember where did I put what, so everything is basically in this def over here. Even though we had a separate function, train model, right? But still, all these variables, their initialization, then calling session.run on the computations. So let me show you the last example today, where we'll organize it in much neater way so that it makes sense, so that we can run the sessions, feed in input data, and have it evaluate. So a best way to do this would be for me to demonstrate to you Siamese network. How do we set it up? And if you recall the Siamese network, what was the loss function? Remember, it was something like half y dw squared plus 1 minus y max of something. There was a margin, and dw n square, something like this, right? Okay, so the beauty of TensorFlow is, like I said, once you are convinced this is a loss function we want, and dw, of course, if you recall, is a1 minus a2 square, right? Okay, so the complication now with TensorFlow is, when we were looking at the Siamese networks, there was one image was fed over here, another image was fed over here. Then based on that, if this is A1, this is A2, we were computing a DW, and then this was feeding to a loss, right? Okay, but in a Siamese networks that we had discussed, these are the same weights. And in reality, we do not build 2 separate networks. We build one network. So we feed in I1, we store A1. We then feed in I2 and make it A2. Then based on the loss, we go and adjust the weights. Okay? So the question is, how do we indicate that in TensorFlow? That it's really, for the first one, store it in A1, second one, store it in A2, then go back and adjust the weights, and the weights are the same. Okay. So that's the part that, again, as you get this handout, as you go through it, try to study it nicely, because, like I said, your next assignments will depend on that. Okay, so the next part of this handout is Siamese network using TensorFlow. So actually, let me do this. Let me show it to you in Visual Studio. Okay, so I organized the code in 2 separate parts. The main simply will read the input data. Okay, so in this case, we will run the Siamese on the MNIST data set. Okay, so this is the main, right? And as you can see, it's basically reading the data sets. And once we have read the data, okay, so now the key thing for Siamese is, okay, our training data, remember, has to be such that if we feed in 2 similar images, what's the expected output? If this is 2, this is also 2,
Then this is 0.
then it's 0. If it is 2 and if this is 4, then this will be 1, right? So we need to create a batch of data where we have pairs like this and the expected output 0 or 1, right? So the first part of the code that you will see over here essentially is doing the same thing. Okay, the batch size at the top, I had declared it to be 128. Okay, then, okay, so TensorFlow already has this next batch built into it. So if we give it the batch size, it will give us the next 128. So you can see there are 128 images as input 1, 128 as images 2. So this is the second set of images. Obviously, some will be same digits, some will be different. Okay, so basically, label 1 equal to label 2 will essentially give us, if they are the same label, then it will give us 0. If they are different, it will give us 1. So simply writing this code will accomplish that. Okay, so Siamese is another class that I put in over here. And now all we have to do is call the train model. So if I go to the Siamese class, okay, so anyway, key thing, like I said, is if you can understand the layout of this particular code, then the variational autoencoder that I created also follows the exact same flow. So basically, as you can see in the constructor, okay, in the constructor we have, is it already 4 o'clock, yeah. Am I right? Okay. Okay, so let me just go 1 more minute. So once you get this code, you will see, I'll just give you the overall idea. Constructor basically creates the placeholders for the inputs. Okay, also points to whatever loss function that we will be using. Okay, so we put it in a separate function. So self.loss, self.optimizer. So very, very quickly, if I take you to the loss function over here. So anyway, then, by the way, there's a layer. Instead of writing a separate class, I just left it as a function. There's a network which assembles the layers. If you take a look, basically, the architecture of the Siamese network is 1024, 1024, and then 2 over here. So it reduces to 2. Okay, so because in a Siamese we need 2 of these, so you will see here's the first layer, here's the second layer, right? And how do we indicate to share weights? And by the way, Siamese network will now assemble it as 2 separate networks. So here's one network, here's another network. And this is how we indicate in TensorFlow. If we say scope.reuse variables, then basically the weights and biases in the first network will be the same as weights and biases in the second network. Okay? So anyway, loss function, if you take a look, this is exactly like we discussed. dw is our square of the distance. Then this is y dw square. So let me see if you can see. Do you see df that power dw2 comma 2, right? Loss negative, there will be 1 minus y, so there's tf dot subtract 1 minus y. Labels is the y, and then whatever there's a margin. So there's a tf maximum, margin, and so on. Okay. Anyway. So that's how in the train, basically, we ask it to evaluate the optimizer, evaluate the loss. This will just do the back propagation, automatically do the recognition or whatever we want it to do. Okay? So look for this handout, and I will ask you to enhance the output a little bit so that you actually get better at it. Okay? All right, we'll continue from here.